everyone, welcome back to my channel. My name is Sevim. We are learning cloud together on AWS Educate. We are on the Builders Lab and this is the third module and we are going to learn together. I hope you are enjoying studies. I really enjoy them. If I had more time, I will probably work on 24/7. This is the introduction and our objectives. A database is a collection of information that is stored and accessed electronically. Databases are designed to meet different needs. Let's read the theory. Different needs for how you access data, common types of relational and non-relational databases. In this course, you learn about the types and databases and key terminology to help you plan, design databases. This module introduces database basics, including the following: database principles, database terminology. Database types. The need for a database solution to support distinct use cases and workload profiles is evident in today's world. Amazon Web Services offers a broad range of database services that are purpose-built for your specific applications. AWS managed database services include relational and non-relational schema-based database. I'm going to just choose each of the following icons for more information about the types and databases that AWS supports. Relational, key-value databases, document databases, in-memory databases, graph databases. Let's start with relational. Relational databases store data with a defined schema. These databases are commonly used for transactional and traditional applications. Key-value databases are optimized to store and retrieve key-value pairs in large volumes and in milliseconds without the performance overhead of relational database. Document databases are designed to store data as documents. Data is typically represented as a readable document. In-memory databases are used for read-heavy and compute-intensive applications that require low latency access to data. Graph databases are used to quickly create and navigate relationships between data. Database offerings at AWS. AWS provides a broad selection of purpose-built database solutions. The following are some of the more common database services divided by the category and type. Relational databases, traditional data warehouse. Relational are Amazon Relational Database Service, Amazon RDS, Amazon Aurora, and again relational data warehouse, Amazon Redshift. Non-relational databases, key-value, Amazon DynamoDB, document, Amazon DocumentDB with MongoDB compatibility, in-memory, Amazon Apache, Amazon Elastic Cache, graph, Amazon Neptune. For more information about AWS database offerings, see AWS Cloud Databases. I'm going to click this, but read it later on. Managed databases offerings at AWS. Using an EC2 instance, in addition to using a fully managed database service, you can host your database on Amazon Elastic Compute Cloud, Amazon EC2. Hosting a database on the EC2 instance offers various advantages and disadvantages. For example, suppose that you are migrating multiple Oracle databases to AWS. You will find that some of them are great fit for Amazon Relational Database Service, Amazon RDS, but others are better suited to run directly on Amazon EC2. Using an RDS instance, using an EC2 instance. Choose each option for hosting a database to learn more about when you might use EC2 instance or RDS instance. Here. Amazon EC2 might be a better choice for the following scenarios. You need full control over the database, including systems, CSYS, system user access, or you need access at the operating system level. Your database size exceeds that 80% of current maximum database size in Amazon RDS. You need to use database features or options that Amazon RDS does not currently support. Your database IOPS needs are higher than the current IOPS limit. You need a specific database version that Amazon RDS does not support. For Amazon RDS might be a better choice for the following scenarios. You want to pay for the database license as part of the instance cost of an hourly basis instead of making a large upfront investment. You don't want to manage backups and, most importantly, point-in-time recoveries of your database. You would rather focus on high-level tasks such as performance tuning and schema optimization rather than the daily administration of the database. Your database size and IOPS needs are less than Amazon RDS limits. You need a highly available database solution and want to take advantage of the push button synchronous multi-AZ application that Amazon RDS offers. At the same time, you don't want to manually set up and maintain a standby database. You want AWS to handle the heavy lifting tasks such as provisioning of the database, management of security patches, minor version upgrades, and more. Benefits of relational databases. The relational databases are still the single most popular and most used database category in the world. In August 2019, DB Engine's ranking relational databases represented 75.2% of the popularity score across all 11 categories of databases that were rated. Among all 351 database engines, the top 4 were relational databases in order: Oracle, MySQL, Microsoft SQL Server, and PostgreSQL. Relational databases have maintained their popularity due to current situation of the market and ease of use. Other factors include their data integrity controls, common shared language among vendors, and excellence of reducing overall data storage. Benefits of non-relational databases: flexibility, scalability, high performance, highly functional APIs. Flexibility. Non-relational databases provide flexible schemas that offer faster and more iterative development. These databases can store structured data, semi-structured data, and unstructured data. Scalability. Non-relational databases are generally designed to scale out by using distributed clusters of hardware instead of scaling up by adding expensive and robust servers. Some cloud providers handle these operations behind the scene as a fully managed service. High performance. Non-relational databases are optimized for specific data models such as document, key value, and graph. They access patterns that provide high performance and trying to accomplish similar functionality with relational databases. High functional APIs. Non-relational databases provide high functional APIs and data types that are purpose-built for each of their respective data models. Data distributions. Partitioning and sharing. Partitioning is a form of distributing data. Partitioning takes the data in a single table or file and distributes it across multiple tables or files by using a partitioning function. Sharding is a form of table partitioning. The system can use sharding to distribute the partitions across multiple databases which can reside in different instances. Sharding provides the advantage of distributing data across database instances. Thus, you can support data growth and have greatly improved throughput for both read and write operations. Data source types. Structured data. Structured data is often organized to support transactional and analytical applications. Structured data is, as the name suggests, that data is that modeled with predefined attributes. Thus, every entry in the database will have the same column heading attributes. Structured data is most commonly stored in relational databases, but can also be stored in non-relational databases. This can source type of valuable because you can gain insight into overreacting trends by efficiently running powerful data queries and analysis. Databases allow only certain types of data into a field. When you create a database, you specify the type of data that can be stored in each field for that column. String. The most common data type is string. A string can contain letter numbers, and additional specific types. Strings are useful to capture names, sentences, addresses, and account numbers that can contain characters and numbers. In this example, the columns account number, amount of data used, and font type are strong string data types. Okay, number. Integer that types only store whole numbers. Those numbers can be positive or negative. However, they cannot contain decimals. Okay, and Boolean. A Boolean data type is used to represent one of two values. For example, when the value can only be either yes or no, true or false. You will use the Boolean data type. Decimal. The decimal data type is numerical value that can have a decimal in it. Data source types. Semi-structured data can be as predictable and organized as structured data. The difference is that semi-structured data is flexible and can be updated without the requirement to change the schema for every single record of a table. Users can use semi-structured data to capture any data in any structure as data evolves and changes over time. Semi-structured data is often stored in non-relational stores. Examples of semi-structured data include extensible markup language, HTML, email, and JavaScript object notations, which is shown. Data source types. Unstructured. Unstructured data is not organized in distinguishable or predefined manner. Common stores for unstructured data are unrelational key-value databases. Unstructured data is full of irrelevant information, which means that data must first proceed to perform any kind of meaningful analysis. Examples of data that are considered to be unstructured are text messages, word processing documents, videos, photos, or other images. These files are not organized other than being placed into a file system, object store, or another repository such as data lake. Database terminology. Vertical scaling compared to horizontal scaling. Scaling a database refers to making the database larger and capable of including more data. There are two ways to scale a database. Vertical scaling. With vertical scaling, scaling up, you increase the available resources on the system that is hosting the database. With AWS, it means resizing the instance. With horizontal scaling, scaling out, you add replicas of the database to distribute the data. At this point, things can become tricky. By distributing the data across multiple systems, you begin to run into issues of consistency, availability, efficiency, query or pattern flexibility, and infinite scaling. Transaction. Transaction is a logical unit of commands that are run against the database. Relational transactions are invoked by using the following statements: insert, add a new record to a table; update, change the values within one record in table; delete, remove a record from a table. Non-relational operations are invoked in different ways in different databases engines. The following operations are in DynamoDB: put item, add a new item to the table; update item, update existing values or add new attributes to an item in the table; delete item, remove an item from the table. Transactional compliance, ACID compliance. ACID is a long-standing bastion of relational data integrity. In a database such as Amazon RDS, a sequence of statements processed together is called a transaction. Millions of transactions can be performed consecutively. The data and the constraints on that data are very active in relational databases. Atomicity ensures that your transactions either completely succeed or completely fail. No one statement can succeed without the others. This interaction is important for avoiding faults in your dataset. Consistency ensures that all transactions provide valid data to the database. This data must adhere to all defined rules and constraints for a transaction to complete successfully. All the statements within it must be valid against all relevant constraints. If any single statement violates these checks, the whole transaction is rolled back and the database is returned to its previous state. Isolation ensures that one transaction cannot interfere with another concurrent transaction. Isolation ensures that when multiple transactions request the same data, rules are in place to ensure that the operations do not cause data corruption. It also ensures that all data is made available in an orderly fashion. Data durability is about ensuring that your changes stick after a transaction has successfully completed. Durability ensures that the result of the transaction is permanent even in the event of system failure. Transactional compliance. Base supports data integrity in non-relational databases. These databases are hyperactive and the primary concern is ability of the data over consistency of the data. To ensure that the data is highly available, changes to data are made available immediately in the instance where the change was made. However, if it might take time for that change to be replicated across the fleet of instances. The aim is that the change will eventually be fully consistent across the fleet. Basically available, BA, provides the ability for one instance to receive a change request and make that change available immediately. The system always guarantees a response for every request. A base, S, A base system makes allowance for partial consistency across distributed instances. For this reason, base systems are considered to be a soft state, also known as changeable state. Letter E for eventually reinforces the other letters in the acronym. The data will eventually consistent. In other words, a change will eventually be made for every copy. Data consistency. Read consistency represents the manner and timing that successful write or update of a data item is reflected in a subsequent read of that same item. DynamoDB exposes logic that you can use to specify the consistency characteristics that you desire for each read request within your application. Eventually consistent. When you read data from a database, the response might not reflect the results of a recently completed write operation. The response might include some stale data. If you repeat your read request after a short time, the response should return the latest data. Strongly consistent. When you request a strong consistent read, the database returns a response with the most up-to-date data. This data reflects the updates from all prior write operations that were successful. A strong consistent read might not be available if a network delay or outage occurs. Replicas. A database replica is a copy of the database on another server. The primary database instance and replica share the same level of information. A replica can be used for database recovery if the primary instance is corrupted or destroyed. Replicas can be read, write, or read only. These were all the database basics. I hope you enjoyed it. I'm going to see you in my next video. Bye.